Great entrance, eh? Coffin up store. All right, Lucas, do you want to explain what we're doing for normalization as I cough up over here?
Yeah, so after Glavin and I finished arguing, we concluded that I'm on the same page as him. He is right. I didn't want to say it like that, but he's right. So the objective, since the objective, like typically to normalize, what you would do is you take the highest number possible in a set, divide all other possible values by the highest number in the set, so that you can basically get a percentage and then multiply that percentage number. Let's say, for example, in our case, 1.4 divided by 0.5, you get 0.35. Multiply that by 100, and you get 35%. So 0.5 ends up being 35% of the maximum. Now, Glavin's argument was basically he wants, if he were operating only 2 of the wheels, such that the car would translate on a 45-degree angle across the room, and it was only running at 0.35%. That doesn't make a lot of sense, because we might as well just let it go as fast as it can. So we're actually going to normalize to the highest number available in any number set instead of in the entire number set. Now that's a little bit challenging to kind of comprehend, which is I think where I struggled as well. Instead of looking at the entire number set, you only look at the number set that's in use at that point in time, and you normalize that number set that's in use at that point in time. And that way you can get the maximum amount of power without affecting the functionality of the vehicle. That's the only way I can really say it, and I don't think that's the clearest way to explain it. But that's where we're going to go with it for right now.
Yeah, let's maximize these motors.
Yeah.
So I think I'm almost done. So what we have here is, oh gosh. So we want to get the maximum of the 2 numbers. We want to make sure they're, gosh darn it, make sure they're the absolute value, because we don't want to handle negatives. We're just talking about magnitude. We don't care about direction. Plus and minus is direction. We just want to know the true value. That's the size of it. And then we want to actually divide this by norm coefficient. And what this is going to do is, let's say we have 1.4, which is the possible maximum. Divide by 1.4 gets 1. So at most, all values are going to be 1. And then we say on top of this, some kind of speed coefficient. And in our case, we want to go to 100. And this is what's going to be interesting, though, is later down the road, we can pick a direction, and we can pick a speed in that direction. That's what this 100 is going to be. So we've normalized our direction down to 0 and 1. So we can go 0 and 1, and we get to pick the x and y components of each of those, and how that breaks down, and how the wheels have to be turning relative to each other. And then from there, we're going to say, great, relative to each other, let's open that throttle out, and that's where 100 comes into play. So, so that 100 is going to be our speed coefficient. Now, there's a problem here, is if we have the whole car stopped, we have 0, what's the maximum of 0 and 0? 0. And if you take something and divide by 0, what do you get?
Yeah.
Infinity. So
that undefined.
Right. So that's something that that I had. So if norm coefficient 0, we'll just make it 0, or make it 1. Sorry. So it will just do nothing. Divide by 1 does nothing. So this is it. So this should normalize everything now. Yeah. What are your thoughts?
Okay. Yeah, that sounds reasonable.
Okay. Yeah. So that should fix the problem we just had. Do you want to go over there and hold on to it so it doesn't fly away on us?
All right. Hit it.
Hit it.
Okay, so we have all reverse.
Right, front, left, forward, all forward. Okay, this is too quick. Give me a second.
These things are properly. Okay. Things are going wrong. In all cases.
In all cases.
Yeah.
All right, maybe let's just start with case by case. Gosh. That's frustrating. So let's just start with it should be going right.
Right? What's right?
Let me start with a different one. We're going to start with front left is going forward and front right. Holy shoot. I'll just do that for 30 seconds. Front left forward, front right is off. 3, 2, 1.
Did the exact opposite.
Okay.
Like front right went backward.
That is okay.
Instead of front left going forward.
Wait. So front left.
Sorry, front right is going backward.
Front right is going back. The other one is off.
Yeah, front right went backward.
All right, 1 sec. Let's try it.
Front left went backward. So could be me. I could have gave you the wrong mapping. Front left forward.
All right, front left forward, front right off.
Yeah.
Okay, cool. So all I did there was just I just switched the motors and then changed where the negative was.
Yeah. Okay.
So it just means our mapping was wrong. I think the code was just off, but I figured that would be the case. All right, this is going to be all forward.
Okay. I would imagine it's not going to work just because of. Go ahead.
Just because it hates us.
Okay, so we got front left forward, front right backward.
What, really?
Front right backward, yeah. Everything was reversed. Literally everything.
That should be all forward.
Yeah, I know. So the front right went backward there.
All right, ready?
Yeah. Yeah, you're good. All forward. So that should fix everything, I would imagine.
So I didn't need the negative. I don't. I don't fully understand that. Okay. Maybe the negative is just for his code.
You didn't need a negative to go forward, but you're probably going to need a negative to go backward.
It will. Yeah, we'll see. No, I was actually like timesing by a negative for one of them because that's what his code was, but
okay.
I guess we don't need it.
Right, try something else.
Front left off, front right forward. 3, 2.
Front right forward, front left off.
Perfect. All right, and all backwards is the last guy. All backwards. Oh, sorry.
Didn't like something.
Execute. It stopped.
Good. That's good.
It's the last. Yeah.
Yeah, good.
So this is where it gets fun.
So now we have
discrete options.
Now we have total control, right?
Total control.
Cool.
And we pick a velocity.
So let's simmer down the velocity. Let's simmer down like your 1 to like 23 or something, and put it on the floor.
Yeah, exactly.
Okay. Walking the dog.
Yeah.
Leash.
All right, 10%.
I'm gonna steal your phone. Just wait.
Holy.
Okay.
it's super long, it's just winded around, I think.
I think it's just the big flat end. Stuck.
Um,
So I'm gonna
yeah.
keep this under control. Put it out like 0.2 maybe.
Yeah, let's yeah.
Start it slow.
All right, 2%.
Don't start it. I'm just trying to focus it.
What is this gonna do? It's just gonna drive backwards. What do we want it to do?
I want you to drive it sideways or something.
Okay, give me a sec. All right, it will drive right, apparently.
Sideways right? Translate right?
Translate right. All right. Are you able to grab it if it decides to drive off?
Yep.
All right. 3, 2. Oh wait, Zach, can you move the camera down a little closer? Or is it zoomed in?
What are you seeing? Not much.
Oh, I think it's rotated. There. Perfect. Yep. All right. Ready for this? 3, 2, 1. So not enough juice.
2 is below the threshold. Maybe change it to 3. 30%.
Oh, I was at 2%. Do you want to go to 10%? 10% being the max.
Sure, yeah.
Okay, 10% it is. Everyone very careful. Ready?
That might not work either, but we'll try it.
3, 2.
I think 20% is going to be our threshold.
No problem. It's easy to change. All right. 3, 2.
Okay, so the translation is partially working. Try it at 30%. It's got some.
All right, ready?
Yeah. Dang. Oh man! That's exciting. Do it again.
All right. It gets better than that.
2 left.
Yeah.
Come back.
Let me come back. I just need to look this up. So left is pi divided. Oh, just pi. All right. Give me a second. I'll be quicker next time. Just adding some some stuff.
Sure.
Math pi. I think this is left. All right, ready?
Yep. Dang. Boom. That's it. Holy shit, this is exciting.
Okay. What else can we?
Do you do an angle? Can you do a diagonal?
Absolutely.
Do a diagonal down left if you can.
Down left.
Yeah.
5 pi divided by 4. Ready? 3, 2.
Dang. And it works well. It's gripping nicely.
Wow.
Wow.
Enough juice. All right, so 30%.
30% is a good testing rate. Okay. So I think that's probably a good place to consider calling it. Big win to end the night.
How quick is it? If it is all, if I want to make it go in a circle,
Oh yeah, you can make it go to circle. Do that. Yeah. Okay. So you do. Okay, let's think about this. I'll push the car around. So if we want a circle, we go. So we go diagonal, 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 diagonal. Right? A diamond. That would make a diamond, not a circle. But
yeah, but we just add more steps in between.
so diagonal. How do you get an actual circle? So it's
Okay, so let's add a new method. This is move in a circle. So what it's going to do, wheel angle, start at 0. We're going to add a part of a circle. So
So four. Yeah. I guess we'll do the 4 quadrants.
yeah. Delay. I need a delay there, and I need to step. So I'm going to break it down into steps and delays so that essentially we can just loop forever. So while true wheel angle plus equals step, and then we just go move with angle, wheel angle, and then we delay, sleep with a delay. So if we want to do it quickly, delay, let's say it was, don't entirely know. Let's say we had a circle. Okay, let's think of it this way. If we had a circle, how quickly would we want it to circle around? And
So-
how many segments we want?
So 1 Mississippi, 2 Mississippi, 1 Mississippi, 2 Mississippi, 1 Mississippi, 2 Mississippi, 1.
So like 10 seconds and
For the entire circle. 10 seconds, like 2.5 seconds each.
yeah. So then that therefore. So if you said it was 10 seconds, how many times do you want to divide the circle? Holy shoot. So 2 pi is a full circle.
Oh, I see. Yeah. What am I doing? I'm still thinking too discrete.
That's right, man. That's
There's
right.
sign. Sign.
So how long? Total duration. We'll make it 10 seconds. Therefore, if we're going to delay count steps, step size. So full circle divided by count of steps. The count of steps is equal to the total duration divided. My God. I need to not be in BIM right now. Total duration. So if I had 10, so that's 100. So I have now 100 steps or count steps. Step count. I want to make it step count. So therefore, if I have that, so we have a full circle. We're going to change the angle of a full circle in a 10-second period. We're going to iterate in a 10 millisecond. No, in a tenth of a second units. Actually, I want to make that smaller. In a 10 millisecond unit. Therefore, the total duration divided by that unit is going to be the number of steps in between. So we're going to move that. We can just do the math so you can see what it looks like. So there's 1,000 steps. A full circle divided by 1,000 pieces. And then for every step, we move the circle by that piece. And move it. Okay. Yeah, that should be it. Move in a circle. The only thing we might have, yeah, I don't know what's gonna happen. It'll be fun. All right, I do need you holding it because I don't know what's gonna do. And also, let's move everything. I don't know how. My concern is how big is the circle, and
Well, do you want to have the camera in your hand then? I'll
Yeah, I'll
catch
well,
the thing. Just press enter and then just have the camera with you. Make sure that you don't have the camera in a way that you can't like take a quick step. 'Cause I don't want you to jeopardize your camera either. But
also, I wanna put it on the big screen. It's not rosary. Oh, it's the video's catching up. That's weird. Oh. There's us. Yeah. So that means our audio is going to be out of sync with the video section. All right. I don't know what this means though. If this is well, the problem is if I move this, you see, it doesn't.
Oh, yeah, that's not real time. That's weird. Here, I'll keep my foot. Take my foot. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
It's because that's
13
why it's
seconds.
buffering. That's why it's growing.
Yeah.
That makes sense. It's not a memory leak. It literally is trying to buffer. Oh my god. All right. Well then, I wonder if there's a way for me to fix that. Sorry for the delay, everyone. Whoever's still with us. Boom. It's caught up.
Alright, cool.
Okay. All right. So this is going to do a circle, whether or not the circle is too big. Like matter of fact, I don't even know if we should put it in the middle.
I'll catch it. If it goes too big, I'll catch it.
Okay. So in a few seconds, I'm going to start. Camera looks good. 3, 2, 1.
That's too sucky.
There. Well, there's the circle. It has enough space to satisfy it. Yeah, that's not bad for first try.
It's pretty damn good. It's got a little bit of slip. I don't think the wheels are different speeds. I think that it's slipping.
Yeah. That might have been what Nick's talking about the drift.
It's not too bad.
Dude, it just keeps going. Look at it go.
So it goes through a reverse, an angle, horizontal translation, angle, straight, angle, horizontal translation, angle.
It should be adjusting it every, well, actually, there it is. You see this stream? That's every adjustment.
Every adjustment.
Yeah. It's doing, what did I set it to? It's hundredths of a second. So 100 times a second is revaluing it. And then adding a hundredth of a circle to its calculation. if it would be more precise if it had higher speed. But yeah, there's just a lot of that.
I wouldn't want to go faster. Anyway, that's good. Let's call it there. That
Wow.
works. That works. First try.
Yeah, man.
Oh yeah. Cool.
Wow.
So we just have to figure out how to get 8 PWM so we can do the more funky
Yeah.
motion.
If we can get 8, then we can rotate and translate at the same time.
Dang.
Which is gonna be some crazy math. I have no idea how to do it, but I'm sure we can figure it out.
Yeah. Yeah, because right now, basically, 2 of our wheel sets are like they're matched for on a horizontal basis. So, for example, this wheel and this wheel are controlled by the same control pins. So that basically means they do the exact same thing. And same with this one and this one. And those are basically jumpered together through this. We'll call it a junction bar for right now. Yeah, basically, you have one control input that goes to both of the wheels, and then another control input that goes to the same wheels, and then copy that same theory for the other 2 wheels. The idea there is you can do all of your horizontal translations forward, and you can do your translations, your forward and reverse directions, and your angular shifts to with only 2 control systems. But you can't do a full rotation. The reason you can't do a full rotation is because to get a rotation, you need all of the wheels. Actually, yeah. So to get a full rotation, you need the paired wheels to do the opposite direction. So I'd have to actually rotate these in the opposite direction, which we don't have it set up to be capable to do that yet, but we will. I'm not quite sure how we're going to do it at this time. We're either going to do it through software by using, I guess there's some libraries that you can use in Python to convert normal general purpose input and output pins to PWM pins, or maybe we can configure some sort of circuit to do some transistor switching and see if we can basically switch a transistor every time we try to operate a PWM pin. So we'll just only allow PWM pin to go to certain motors when we tell it to through hardware. Not sure which direction to go yet. We'll find out. Anyway, that's probably a good place to end the stream. I think that was a huge success at the end of the day.
Yeah. Super pops. I'm just glad that worked. Want to put it down and try it again.
Yeah.
I want to put it down and try it again. I just want to see it.
Let's end the stream and then we'll play with it.
I want to play more. All right, everyone. We're going to go.
All right, thanks everybody.
Thanks very much. Oh, one sec. I got to find my...